crazy. It's going to follow all the same rules as like square roots, parabolas, da 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 da. They all follow the same rules. So I'm going to give you like a general, what does this look like at the top for any exponential function. So your normal exponential function is y equals ab to the x, right? We are not doing any stretching or shrinking that we're going to talk about. We're just going to explain how something would be shifted, so either horizontally or vertically. Okay, so that's just a plain non-shifted y equals ab to the x. Okay, if you have some shifting going on, and I'll just write it all in one, it would be ab, and I'm going to write the exponent would be x minus h, and then out to the side would be plus k. Okay, works the same way as some of these other, or all these other functions that we've, bless you, talked about. With the x, it's going to go the opposite way you think. So if it looks like a minus 5, it actually goes to the right 5. Opposite way you think, and that is going to be shifting the graph left or right. That is called a horizontal shift. And the k is outside, not with the x, the k is outside. That's going to move the graph up and down the way you think. Or up or down, not up and down. Up or down the way you think. So if it's plus 3, we're going up 3. If it's minus 5, we're going down 5. Up or down the way you think. And that is the technical thing. This is a vertical shift. Up or down is shifting vertically. All right. So all I'm going to do in this very first question is I'm just going to give you just a general form. This is y equals 2 times 1/3 to the x. Okay, now each one of these literally just says, like, tell me what's going to go on here. Is it going to go left, right, up, down? Is it going to flip over? Just based on looking at the equation. So there's my original equation, 2 times 1/3 to the x. Okay, so if I just change this up and I write y equals negative 2 times 1/3 to the x, how would that manipulate that first graph? Yes, anytime if you start out with a negative, that's just called a reflection over the x-axis. Let me just for this one draw you a general shape. Okay, for that original graph, that would be, bless you, exponential decay, right? Because it's a positive a value, the b value is between 0 and 1. So the general shape of that graph, for actually all of these except this one right here, would look like kind of like a backwards J shape. Now, if you flip over the x-axis, this first graph just as a shape, so you would see it, it would literally just like flip down the entire graph if we had that on a grid. All the rest of these are going to look the same as that little sketch I just drew. They would just be shifted to different parts of the graph. Okay, so my second one says y equals 2 times 1/3, and then the exponent's different than the original. It says x plus 3. Okay, anybody raise your hand. How would that shift the graph? Yes. Okay, so this is just going to go left 3. That's it. Opposite of what it looks like. It's what would set that exponent equal to 0. Okay, what if I give you 2 times 1/3 to the x and I say minus 6? How would that shift that original graph? Down 6, that's it. Nothing going left or right because you just have a plain, I didn't write the 6, down 6. I don't have anything in the exponent, so no shift left or right. Something to the side of the expression with the exponential, we're going to go up or down. Okay, now the last one should have 2 parts to its description. So I have 2 times 1/3 to the x minus 4 plus 7. Like, what would you write down for how that would be shifted from that original?
Right 4 up 7.
Perfect. Okay. Right 4 up 7. That's all I'm looking for. If it asks you to describe the transformation, I don't need a paragraph. Just like right this many, left this many, up this many, down this many. Or if you start out with a negative, it's called a reflection over the x-axis. Okay. So on the graph here, and I put this already, like basically the version that's not shifted, I put it on the graph so you guys can actually see the transformation and how this would be different. So this is on the graph right here, and it's going to ask us to transform the graph to be 3 times 2 to the x plus 5. All right, so the original graph is y equals 3 times 2 to the x. That's on the graph right there for you. So if I was going to do 3 times 2 to the x plus 5, how would that be different from the graph that's already on here? Yeah, it would be up 5. That's all I'm looking for. Now, before I get into this and draw this, the given graph here, right, just to review from last time. So any domain for any of these exponentials, and whether we shift them or not, it's going to be the same. It's going to go negative infinity to infinity, or if you guys prefer, just write all real numbers, that symbol, that's maybe faster. But you will, no matter what type of exponential you are working with, if it's growth, if it's decay, if it's neither, they all go left and right forever. They'll cover the whole x-axis. Now the range you got to pay attention to. So if you guys remember, these graphs will have an asymptote that they'll get really close to, never touch, never go over. For the graph that's already on here for you, it's not shifted in any way. And so the asymptote, if it's no shifting at all, should just be the x-axis. The equation of the x-axis, though, is y equals 0. So y equals 0, nice four horizontal line. I don't know why I just wrote that on the range. Fired. Okay. Now, the range is related to that. Forgive. All right. The range, you don't touch anything till you hop over that asymptote. And so it's a parenthesis, not a bracket, because you don't actually ever touch 0. And then it goes to infinity. Remember, if we plug in numbers for x that are negative, you just get tinier and tinier and tinier fractions, but they never technically reach 0. They get really close to it, but they never touch it. And the asymptote, my fault, is the y equals 0. Now, if we're going to shift the graph, if it's just up or down, I would just do exactly what we were doing on Friday, where I would do a couple negative, couple positive, and 0. And if you want to physically plug those numbers into that equation and find each one individually, you could do that. Or if we want to maybe use our resources a little bit, I would go to the y equals button on my calculator. Ugh, who messed with my calculator? Okay, hang on a second. My calculator's messed up. You guys go ahead and type that in. I have to fix my calculator here real quick. And if you guys remember, you can get to the table by hitting second graph after you type the y equals in. Okay, sorry, I had to reset my calculator real quick. So I'm doing 3 times 2 to the x, and then you got to arrow over to do the plus 5. And then just hit second graph, and you can scroll up and down. I usually just do like -2, -1, 0, 1, 2. That should give you a decent idea. And you can write decimals or fractions, whatever is easier for you, but I'm just going to write down at least 5 points. If you want to write more, go ahead. And if it's not a nice number, just do your best to estimate on the graph where it would be. So like I got -2, 5.75, so I'm just going to kind of go close to the 6. I got -1, 6.5, so I'm just going to go best I can between 6 and 7. 0, 8's on a nice point. 1, 11 is on a nice point. And 2, 17 will also be on a nice point. Does anybody know what the asymptote should be for the shifted graph? Yes, it's just whatever you're adding or subtracting. So y equals 5. I'm just going to grab my highlighter real quick. So I should get really close to 5, but never touch it, never go over it. If you all are looking at your table, if you started to scroll up, like on the table, you'll see these numbers get closer and closer to 5. The decimals just go, sorry, it's kind of blurry on the screen here today, but it gets closer and closer to 5, but it's not ever actually going to touch it or go over it. So when I'm shifting this, I'm just going to kind of do my best to kind of draw that same shape. The domain is going to be exactly the same as the original graph. All these exponentials, they go from -infinity to infinity. What I'm doing is I'm just taking this and I'm dragging everything up 5 units is what I'm doing. So the range would be different. The range, if it's pointed up, should just be parenthesis with your asymptote. Here it's going to be 5, and then it goes up forever, so it's still going up to infinity. But if you're doing the range for an exponential, as long as it's growth or decay, if it's pointed up, it should just start with the asymptote and then go up to infinity. And if it's shifted, that asymptote might not be the x-axis if it's added or subtracted like it is here. Does anybody have a question? Yeah.
Would K always be your asymptote?
Yes.
Y equals-
Yep, for sure. For sure. Definitely. Okay. If you guys are, I'm going to do one more with the 3 times 2 to the x. If you guys are working ahead of me, though, do me a quick favor. Like the one in the middle on the back, Miss Grody is an idiot and didn't make the graph go low enough. Change that to a +3 for me. We should be okay. Just change that to a +3 because my graph does not go low enough to do the -3. So forgive on that middle graph. Now, let me talk to you before we get to that, just in case if you're working ahead. Now, same graph we actually just worked with, so 3 times 2 to the x. The difference here is the shifting is not to the side, it's 3 times 2 to the x plus 1. Okay, how would this graph be different than the original that's on the paper there? What do you think? Yes, okay, now, if you shift right or left, I would alter what I do with the table. So I'm going to do that in 1 second. Let me go ahead, the given graph there, negative infinity to infinity, 0 to infinity, and y equals 0 is the asymptote. Okay, this is like a really minor shift. We're just going to take that graph and we're going to scooch it to the left one. So it's really not going to move very far. But what I would tell you to do differently when you do the table, okay, this is going to go left 1, right? It's going to go -1. Whatever that number is, I would put that in the middle of the table. If you shift left or right, whatever would set that exponent equal to 0, I would make that the middle of the table. Because really what that is, it's like your new y-axis. We're going to take this graph and shift it over just so the points look good. So if you're shifting left or right, just put that number that would make that exponent 0, put that in the middle of your table. So then I would do like -2, -3 for a couple more numbers negative, and then I would do 0 and 1 for a couple more numbers that are positive. So that way it's going to kind of give you a better idea of the graph. So whatever would set that exponent equal to 0, put that number in the middle of the table, do a couple smaller, couple bigger, and that should give you a really good picture of the graph. Now, if anybody has an 83, if you want to use the table feature, when you do the exponent here, you would have to put parentheses. You'd have to do like x plus 1 in parentheses. If you have one like mine, you don't need to worry about that if you can see the exponent. But if you have the 83, you have to put parentheses around the x plus 1 if you want to use the table feature. If you want to just do it on the screen, you could do it that way too. So if I type that in, all right, I'm going to get like 0.75, 1.5, 3, 6, and 12. And that'll should fit just fine on the graph there. So just kind of do your best to estimate if it's not on a nice point. And it should just, everything should just be scooched over to the left 1 point. So like if you're comparing, like my graph is going to have the point 0.06. The original graph had the point 1.5. So it's just scooching everything over one spot to the left. If I got like 1.12, the original graph had the point 2.11. So the new graph has the point 1.12. And what is the asymptote for this new graph? Yes, they actually have the same asymptote because we're just shifting them. So y equals 0 is going to be the asymptote for both of them here. Now, if I want to play connect the dots with my graph, it'll almost run right next to the other. It's just scooched over just one spot. So then for my transformation domain for all of these, negative infinity to infinity, all real numbers, because you're going to go left and right forever. The range might be different. In this case, it's not. I don't have a shift up or down, so the range here should be the same as the original graph, 0 to infinity. The asymptote is not shifted because I don't have something added to the side, so it actually has the same asymptote as the original graph as well. Is anybody having a question? Okay, now this last one is a decay graph. The first two we did were both growth and they were shifted. And you did me a huge favor and you changed that to say +3 because Ms. Grody did not make the graph go low enough to do the -3. Okay, so now we're going to go up 3 and write 2. The original graph that's on there, -infinity to infinity. And even though this one's decay, the range is 0 to infinity. It just goes up on the left instead of up on the right. The asymptote is the x-axis. Okay, so for our shifted graph, remember, if you have a movement left or right, this one goes to the right 2. Make that number that would set that exponent equal to 0, make that the middle of your table. It'll give you a better picture of the graph. And then I'm going to do 1 and 0 as my two smaller numbers. And I'll do 3 and 4 as my two bigger numbers. Whatever sets that exponent equal to 0, put that in the middle of your table. Just do a couple smaller numbers, couple bigger numbers, and that should give you a really good picture of your graph. Okay, now, what should the asymptote for my new graph be? 3. So I might just go ahead and I'll just draw that in right now so I have it. But let me write down what these points should be. Now, this is 4 times 1/2 to the x minus 2. If you've got an 83, put that x minus 2 in parentheses, close the parentheses. If you have an 84, just use the arrow key to get back down on the level with the rest of the equation to add the 3. And I'm going to write these down. So I got 0 is at 19, 1 is at 11, 2 is at 7, 3 is at 5, 4 is at 4. And if you want more, like 5 is at 3.5, and then they'll go down, they'll get closer and closer to 3. Just do your best to estimate. 0 would be like the very top of the graph. I think most of these are going to be nice points on here. It should not go below that asymptote or touch that asymptote. And then from the original, this is going to scooch over 2, but then also it's going to scooch it up 3. The domain, every single one of these should be all real numbers. The range, if you got a shifted graph, the range is just, it's exactly what Trey said. It's whatever the asymptote is. So it's just going to be 3 to infinity. Your asymptote is y equals 3. They're always going to be a horizontal line. So horizontal, it's y equals 3. All the y coordinates are 3 along that line. And I just put that original graph on there so you guys can kind of see how that is shifted. So we're going over to the right 2, and then we're going up 3. Does anybody have any questions? Okay, now this is just going to ask you to write an equation. So no graph here, just write me an equation. And what we're going to transform is just y equals 4 to the x. Now, if you guys think about this just for 1 second, the a value there, which you do not absolutely have to write in, but it would be 1 times 4 to the x. So just to keep that in mind, this is in that format. It just doesn't put the 1 in front. So if I wanted to take that graph and move it 6 units to the left and up 10, what would my new equation look like? If I wanted to go left 6 and up 10, how would you take y equals 4 to the x and rewrite that?
4 to the x plus 6 plus 10.
Perfect. Okay, now domain doesn't matter. Every single one of these is an exponent. I can just do this right now. I'm just going to write all real numbers. Now, would that shifting affect the range if we put that graph and the 4 to the x on the same graph and looked at it? What would the range be if I did this shifting, or would it be? What do you think? Good. This is going to be 10 to infinity. And then your asymptote should just be anything that you've added or subtracted. Okay, what if I told you I wanted to take y equals 4 to the x, reflect it over the x-axis, and move it down 5 units? Mm-hmm. Yep. No, you're good. Yeah, nothing in the exponent with the x. Up or down is going to be outside. So then, now, the asymptote here, right, would be at -5. Now, before you tell me the range here, I want you to think about how this graph would turn. What would you write down for your range if you did this? What do you think? There you go. This would be -infinity to -5. Because it's going to flip it over, but it's going to scooch it down 5. So it would point down forever, and then it would be stopped at the -5 if we were looking at it on the graph. Okay, what if I just told you I just want to take that original graph and move it to the right 3? How would you write the exponential for that? 4x minus 3. Okay, what would that make your range? What would your asymptote be? Yes, so if it doesn't have something added or subtracted to the side, your asymptote should just be the x-axis, which is y equals 0. Is anybody having a question?